Thank you for choosing American Pest CEUs. Hi, I'm Sean Reeves. I'm an Associate Certified Entomologist with American Pest CEUs. I've been in the pest management industry since 1999, and I'll be your instructor for today's course. Today's course was compiled by Jack Launius, who has served in the pest management industry since 1990. The first part of today's training is going to be on Core Chapter 11, Doing It Right. After studying this chapter, you should be able to name several different application procedures and types of equipment, discuss appropriate safety systems, e.g. closed mixing and loading, enclosed cab, and pesticide containment. Identify the factors, e.g. nozzles, volumes, pressures, and speeds that affect calibration. Explain the importance of calibrating application equipment. Show how to calculate the size of the application area. Indicate how to determine the pesticide application rate. Demonstrate how to determine the amount of pesticide concentrate and diluent to use. Explain how to choose appropriate drift reduction practices. Today's pest management practices require modern equipment to apply a variety of pesticides. Pesticides may be applied as sprays, dust, granules, gases or vapors, fogs, baits, rubs, or dips. The vast array of application equipment must be matched to the pesticide as well as to the size and type of the job. To make an effective, safe, and efficient application, read the label first. In addition, you must properly select, operate, calibrate, and maintain your equipment. So as we're setting the table for what we're going to learn today, you need to understand the different types of pesticide formulations and how different types of equipment are going to be used based on those formulations. So obviously, let's say we're using a granular formulation. Typically, that's going to be used in a spreader or something like that. It's not going to be used in a pump sprayer. So you have to understand what type of product you're using, and you have to match it to the application equipment. Always read the label first. You're never going to make an effective, safe, and efficient application without reading that label. And as all of you probably already know, reading that label is the federal law. When you do select your equipment and you understand what's on the label, you must properly understand how to operate the equipment, calibrate the equipment, and maintain that equipment. Let's talk about different types of applications. One of the important themes in this course is going to be these types of applications. First, let's look at a band application. This would be when you're applying a pesticide in parallel strips or bands, such as between or over rows of crops. A second type of application could be a basal application. This would be directing herbicides to the lower portions of brush or small trees. Or what about a broadcast application? This would be uniformly applying a pesticide to an entire area or field. Then we have a crack and crevice application. This would be placing small amounts of pesticides into cracks and crevices in buildings, such as along baseboards and in cabinets. We also have the directed spray application. In this method, you would specifically be targeting pests to minimize pesticide contact with non-target plants and animals. Finally, we're going to look at a foliar application. This would be directing pesticide to the leafy portions of a plant. Now there's probably something you noticed just getting out of the gate. You're making a lot of decisions out in the field. You're deciding which type of equipment, but also which type of application procedure you're going to use. A lot of you are going to work under a certified operator, certified applicator, supervisor, whatever your state calls them, and they're going to help you make some of these decisions. But let's be honest with ourselves. As applicators, we're making a lot of decisions out there in the field as well. So you fully need to understand these different types of applications, and you need to understand when to do them, how to do them, and why you're doing them. Now at this point, I hope you're getting it. You are a professional in this industry. Think about all the training you have to go through. Think about all the courses you have to take, the exams you have to pass. The reality is you are a professional. As a professional, you're in charge of a lot of things out there in the field. You're in charge of your safety, you're in charge of the safety of others around you, you're in charge of the total environment and your impact on it. So just keep in mind, this is a very professional career with a lot of responsibility, and you are the one that's going to make the right or wrong decisions when it comes down to it in the field. Now in this image, you're seeing what a band application looks like. Once again, this is applying a pesticide in parallel strips or bands, such as between or over rows of crops. So as you can see here, we've got the application equipment actually spraying this field in bands. This is definitely more of an agricultural or farm type of application. On this slide, we're looking at a basal application. This is going to be directing herbicides to the lower portions of brush or small trees. And we've got a few images here where you can see a couple gentlemen doing these basal types of treatments to brushy areas, to the bottoms of tree trunks. This is just going to be directing those herbicides to the lower portions of brush or those small trees. Many of you have probably seen this throughout your time and seen somebody doing these types of applications. Next, we're taking a look at a broadcast application. This is going to be uniformly applying a pesticide to an entire area or field. Once again, this is very common in farm settings and agriculture, although you would probably see this on areas like golf courses and big areas of landscape. More commonly, though, this would be an agricultural treatment. The bottom line is that you're trying to get the pesticide over an entire area, and it needs to be applied in a uniform application. So that means it needs to be applied evenly over that area. Where you're going to get in trouble on this one is if it's not uniform, you're going to get more product in some areas, less in others, and that's going to defeat the purpose of this broadcast application. Now in the instance on the screen, you're seeing more of a residential or commercial building type of application. This is going to be the crack and crevice application. This is going to be placing small amounts of pesticides into cracks and crevices in buildings, such as along baseboards and in cabinets. This has been a common practice throughout the history of pest control. Now, a lot of people will tell you people to just go in and spray these cracks and crevices or baseboard jockeys. I would say this: you need to look at every situation independently, and you need to decide what type of method is going to work best. Don't let somebody tell you one method won't work or one's better than the other. Yes, you can listen to some people that are above you, supervisors, certified applicators, things like that, but you need to make the decision based on the knowledge you gain to what's going to work best for the pest you need to treat at that moment and what's going to need to be done to keep people around you safe. Our next type of application is going to be a directed spray application. These types of applications specifically target pests to minimize pesticide contact with non-target plants and animals. And as you can see in the images here, you really need to think about this type of application. Directed spray applications have a good place, as you can see in some of the images here, with the technician treating around the perimeter of a home. You're seeing a commercial treatment on the left. You're also seeing some agricultural treatments. Just keep in mind, when we talk about minimizing pesticide contact with non-target plants and animals, we have to look at the fact that when you're doing an application like this, you need to know what the wind speeds are. Because if it's a really windy day, you're going to defeat the purpose, as I've been talking about with these applications, as far as you're going to have a bunch of drift of the product, and you're going to do exactly what you don't want to do, and that product's going to get carried somewhere where non-target plants and animals, and even humans, or whatever the case may be, are going to be in some sort of harm. Here we're looking at a foliar application. This is going to be directing pesticide to the leafy portions of a plant. So this again would be pretty common in agriculture, but also in lawn and ornamental treatments on commercial and residential properties. I just want to note that another important factor when you're doing a foliar application is consistency of the treatment. You can't treat these foliar areas, these leafy portions of a plant, and have inconsistent application. You have to apply the product consistently to get the intended result. If you get it where there's a spot here, a patch there, your results are going to be all over the map and you're not going to accomplish what you're looking to do. Let's look at more types of applications. As we look at more types of applications, we're going to have rope wick or wiper treatments. This is going to be releasing pesticides onto a device that is wiped onto weeds taller than the crop, or wiped selectively onto individual weeds in an ornamental planting bed. Also, we're going to look at soil application, placing pesticide directly on or in the soil instead of on a growing plant. We're going to look at soil incorporation, using tillage, rainfall, or irrigation equipment to move pesticide into the soil. We're going to look at soil injection, applying a pesticide under pressure beneath the soil surface. We're going to look at space treatment, applying a pesticide in an enclosed area. We're going to look at spot treatment, applying a pesticide to small, distinct areas. And we're going to look at tree injection, applying pesticides under the bark of trees. With rope wick or wiper treatments, this is going to be releasing pesticides onto a device that is wiped onto the weeds taller than the crop, or wiped selectively onto individual weeds in an ornamental planting bed. So this is going to be really common again in farming and agricultural types of treatments, and can also be used on weeds in an ornamental planting bed as we've just talked about. A couple of instances where you might use this, you would use this to control weeds growing above crops, where that herbicide that you would put down would damage the crops, so you only want to treat those weeds growing higher above, as well as in landscaping areas too, where you just want to treat the weeds, but you don't want to kill those ornamental plants below by treating them with the herbicide as well. Next, we're looking at soil application. This again is going to be placing pesticide directly on or in the soil instead of on a growing plant. So as you can see here, a lot of times this would be a commercial or farm type of application. But obviously you can think of things like a termite treatment where you dig a trench. There you would also be putting termiticide into the soil itself. Now another type of treatment could be soil incorporation. In this instance, we would use tillage, rainfall, or irrigation equipment to move pesticide into the soil. Now as you can see here, this is typically an agricultural or farming type of application. Next, we're looking at a soil injection application. This would involve applying a pesticide under pressure beneath the soil surface. So as you can imagine, this would be in farming and agricultural applications, as you see on the two photos on the right. But also this could be done in ornamental beds and plant landscapes. It could be done for things like termites. So this is a pretty common application you would see in commercial pest control as well as farming and agricultural. The next type of treatment we're going to look at is a space treatment. This would involve applying a pesticide in an enclosed area. So this could be a lot of different things. As you can see in the upper right, this could be something in greenhouses. This is something I've seen in warehouses, in factories, in grain bins, in railroad cars. There's pretty much no limit to where this can be done. I've also seen these types of applications even in residential structures. Although they're not as common, there is some types of treatments you can do in those as well. But there's a lot of different things you're going to need to learn about space treatments, because as you can imagine, when you're applying a pesticide in an enclosed area like this, there's a whole lot of issues that can come out of that if you're not careful. Next, we have a spot treatment. This would be applying a pesticide to small, distinct areas. And a lot of times when we talk about spot treatments, you're going to see on the label what a spot treatment is. So a lot of times it'll even say on a label 2 feet or less or something like that. But just keep in mind, a spot treatment is going to be a small, distinct area. Our next treatment type is tree injection. This would be applying pesticide under the barks of trees. This would be something that would be common in parks areas and even in commercial and residential landscapes when you're trying to protect trees from insects and disease. This could also be something done by the forestry department in certain areas. So keep in mind there's a lot of different applications and a lot of different ways this could be used. Let's talk about safety systems. Closed mixing and loading systems, enclosed application systems, e.g. enclosed cabs and pesticide containment systems, are excellent investments if you use large quantities of pesticides or the kind that is very hazardous to humans or the environment. More on closed mixing and loading systems. They are designed to prevent pesticides from contacting handlers or other persons during mixing and loading. Sometimes the label of pesticides with a high risk of causing human health effects may require the use of a closed mixing and loading system. There are two primary types of closed mixing and loading systems. One type that uses mechanical devices to deliver the pesticide from the container to the equipment. The other type uses water-soluble packaging. Let's talk about those mechanical systems. Mechanical systems often consist of a series of interconnected equipment parts that allow for the safe removal of a pesticide concentrate from its original container, either by gravity or by suction. These systems minimize exposure when rinsing the empty container and transferring the pesticide and rinsate to the application equipment. Mechanical systems are often custom-made with components from several commercial sources. These systems are available for containers as small as 2.5 gallons. Because pesticide container openings vary in shape and size, no single closed system can be used with all containers. A mechanical loading system is often used with mini bulk containers. These containers range in volume from 40 to 330 gallons and are adapted to closed systems. Typically, pump and drive units deliver the product. A meter allows accurate measuring from the mini bulk tank to the sprayer. Mini bulks usually must be returned to the dealer for refilling. This process eliminates the need to triple rinse or pressure rinse multiple small containers and reduces the volume of used plastic containers. Let's talk about water-soluble packaging. Water-soluble bags are a simple type of closed mixing and loading system. The pre-measured pesticide is contained inside a water-soluble bag or packet. The pesticide bag is placed unopened into the water or fertilizer in the mixing tank. Few manufacturers, however, provide water-soluble bags for small volume applications. There must be ample time during mixing to allow for the bags to dissolve. In essence, these water-soluble bags are acting as a closed mixing and loading system. So that pre-measured pesticide is already inside that bag. One of the big things you have to remember that we mentioned at the bottom, there must be ample time during mixing to allow for the bags to dissolve. Make sure you read the label on this, because if those bags are not fully dissolved, they're not going to be ready to use, and what you're going to get is a mix rate that's out of proportion, or the bags haven't really dissolved at all, and you're going to get a bunch of pesticide all at once, or you're not going to get any at all. So make sure you follow the label on how long it takes for these bags to dissolve and be ready to use. I think it's a good time to talk about a portion of a label on this. To prepare the spray mixture, remove the outer foil pouch and drop the required number of unopened, clear, water-soluble packets, as determined under Applications, into the spray tank while filling with water to the desired level. Operate the agitator while mixing. Depending on water temperature and amount of agitation, the packets should completely dissolve within a few minutes after they are added to water. Allow longer time for the clear packet to dissolve when using cooler water. So this label tells us something that's very important. These packets should dissolve within a few minutes depending on the water temperature, but if it's cooler water, give them a little longer. So what is a few minutes? Let's just say 5 to 7 minutes. Just make sure you can see that formula is mixing and dissolving, but this just gives you an idea of what this looks like when reading a pesticide label. Let's talk about enclosed cabs. An enclosed cab, such as a tractor cab, cockpit or truck, vehicle cab, surrounds the occupants and may prevent pesticide exposure as long as the doors, hatches, and windows are kept closed at all times during the application. Enclosed cabs are considered a supplement to personal protective equipment or PPE, not a replacement for it. So, you must wear all PPE specified on the label while working inside the enclosed cab. So the enclosed cab can definitely help protect you some from pesticide exposure, but you always want to wear the PPE anyways. Don't put yourself at risk, and don't think just because you're inside that enclosed cab that pesticides cannot make their way in. Always be safe and always wear the correct PPE even inside the enclosed cab. However, the labeling of some agricultural use pesticides may allow exceptions to the label specified PPE requirements for applicators in enclosed cabs. Check with your state, tribe, or territory pesticide regulatory agency for any other requirements regarding PPE in enclosed cabs. Remember, outside surfaces of the application equipment and cab are contaminated. Be sure to wear appropriate PPE when getting in and out of the cab or performing routine equipment maintenance. I think this is common sense, just understanding this. Obviously, if the label tells you don't have to wear PPE, then you don't. Although it's always good to wear it to definitely make sure you're protected, and you can always go above the label. But just keep in mind that if the label says you don't have to wear PPE, then you're not required to by law. You have to remember, though, as soon as you step outside of that cab, wear the PPE. And this gets back to the point. Why not wear the PPE even when you're in the cab? So when you get out, you don't worry about touching something that's contaminated and then getting pesticide exposure. Pesticide containment systems. If you often use the same location to mix and load pesticides or clean equipment, you may have to install a pesticide containment pad. Check U.S. Environmental Protection Agency and state, tribe, or territory regulations to determine when a containment pad is required. Keep spray tanks containing pesticides on a pad. These pads are designed to contain spills, leaks, overflows, and wastewater for reuse by the applicator or disposal by a commercial waste management contractor. They make it easier to clean up spills and help prevent environmental contamination. And just so you know, a lot of times you'll see questions like this on core exams because it is a really important thing. Anytime you're using the same location to mix and load pesticides or clean equipment, it's a really good idea to install a pesticide containment pad. So you want to make sure there's not pesticide buildup in that same area over and over again. And a lot of times this could even be from things as we talked about here, spills, leaks, overflows, and even wastewater. You have to make sure that a containment pad is down there to soak this stuff up, because if not, really what you're doing is you're polluting the environment around you. Use a permanently installed containment pad to mix, load, and clean equipment, and in areas where large quantities of pesticides are handled or stored. Generally, the containment pad must be made of impermeable material. It should be concave or have curves, berms, or walls high enough to hold the largest amount of spill, leak, or equipment wash water likely to occur at the site. It must also be equipped with a system to remove and recover spilled, leaked, or released material by either an automatic sump system or a manually operated pump. Smaller, portable pads and lightweight trays made of heavy-duty plastic may be used when mixing and loading at the application site. Again, check regulations for containment pad design requirements. In this image, you're seeing a permanent containment pad. And as you can see, this one covers a pretty large area, so you can understand why we're saying no matter what we're doing with pesticides, mixing, loading, cleaning equipment, or whatever in that area, we've got a nice permanent containment pad to pick up those pesticide residues and make sure they don't get into the environment. Speaking of application equipment, the application equipment or device must be able to apply the pesticide to the intended target at the proper rate. The label specifies the legal application rate and may suggest the appropriate equipment for use with the product. Application equipment may range from an aerosol can to hand equipment to power equipment, including aircraft. The equipment may be carried, towed, or self-propelled. Let's talk about sprayers. This is going to be the most common type of pesticide application equipment. Nearly 90% of all pesticides are formulated for spraying. A hydraulic, liquid sprayer uses water or other liquid carrier for the pesticide. However, in the case of ultra-low volume spraying, the pesticide is either applied directly as formulated or with dramatically reduced carrier volumes. Hydraulic sprayers range from large agricultural sprayers with multiple nozzle booms and power sprayers to small manual backpack and handheld compressed air sprayers. In all cases, pressure from either a pump or compressed gas or air is used to atomize the spray mix at the nozzle. And as many of you already know, this is going to be the most common way to deliver pesticides. Probably at least 90% of you are going to work with these handheld types of sprayers. So just keep in mind, you definitely need to know and understand these sprayers. You need to know what their uses are. You need to know what their limitations are. Because again, most of you are going to be using these at some point in your pesticide career. Speaking more on sprayers, manual sprayers are designed for spot treatments and for areas unsuitable for larger units. They are relatively inexpensive, simple to operate, maneuverable, and easy to clean and store. Adjustable spray guns are often used with these units, but some models have the option for a spray boom. The Air Blast or mist sprayer uses both water and air as carriers. Spray droplets are formed by the nozzles and delivered to the target by an airstream. Air blast sprayers are typically used for disease and insect control on fruit trees, vineyards, vegetables, and Christmas trees. We also need to look at the sprayer's components. Because sprayers use water or other liquids to dilute and carry a pesticide, a tank is necessary to contain the spray mix. Choose a tank made of or coated with a material that does not corrode and can be easily cleaned. Corrosion and dirt clog screens and nozzles and increase wear on the equipment. Large tanks require an opening in the bottom to aid in cleaning and draining. A large top opening is useful for filling, cleaning, and inspecting the tank. The opening must have a watertight cover to prevent spillage. A tank agitation system or device is useful for most sprayable formulations, especially for wettable powders or dry flowables. Constant mixing of a pesticide and liquid carrier produces a uniform spray mixture, suspension or solution, resulting in an even application of the chemical. Sprayers use a pump to produce the flow of spray material to the nozzles and for agitation. The pump parts must resist corrosion and be abrasion resistant, especially when wettable powders or other abrasive formulations are used. Never operate a sprayer pump at speeds or pressures above those recommended by the manufacturer. You may damage the pump if it is operated dry or with a restricted flow at the inlet or outlet. Pumps depend on the spray liquid for lubrication and to prevent overheating. One piece of information we've introduced on this slide is the fact that when you're dealing with a sprayer, and especially with all the different parts in it, you also have to know how to operate that sprayer. Now, I know you've heard about reading pesticide labels and how important that is. Operating the sprayer is also important. You've got all these different things you got to follow on that sprayer, because if you don't, if you operate at too high of a pressure or too low of a pressure, technically we're also not following the label. In addition to that, you can damage the equipment if you operate it outside of these manufacturer specifications. So I want you to understand the spray equipment is just as important as the pesticide and the label, in as much as you need to do the things you need to do with the sprayer as well as the pesticide itself and what the label calls for to be within the tolerance of the law. Nozzles control the amount of material applied, droplet formation and size, coverage and drift, and the distribution and pattern of the droplets. A nozzle spray pattern is made up of a wide variety of spray droplet sizes. Nozzles are classified based on the spray pattern they produce. The size of the nozzle opening or orifice affects the droplet size and flow rate. A nozzle that primarily produces larger droplets is most likely to minimize off-target drift. A nozzle that mainly produces smaller droplets will maximize surface coverage of the target. Choose nozzles based on the target pest, type of application, coverage desired, and drift potential. Now there's going to be a lot of choices with nozzles. Nozzles are available in various materials: brass, aluminum, plastic, stainless steel, hardened stainless steel, and ceramic. Select the nozzle material best suited for the pesticide formulation. Never use brass or aluminum tips to apply abrasive materials such as wettable powders and dry flowables because they wear too fast. Since wear destroys the proper working of a nozzle, replace worn nozzles. To reduce wear, use nozzle tips made of a hard, wear-resistant material such as plastic, hardened stainless steel, or ceramic. Also, be sure you have the correct nozzle screen size for each nozzle. Flow meters and other devices measure nozzle flow rate and the uniformity of flow from nozzles along a boom. It can be used to check nozzles for output and is useful during calibration, particularly when sprayers are set up with multiple nozzles. This image gives you a quick idea of just exactly how many different nozzle types there are. Again, the main thing when selecting a nozzle type is going to be the product you're using and the intended use of the application. Another type of applicator is going to be a granular applicator. Granular applicators are available for either band or broadcast application. They may be operated as separate units. However, they are often attached to other equipment, such as planters or cultivating equipment, to combine two or more operations. Granular applicators usually operate by gravity feed and have an adjustable opening to regulate the flow. And I think a simple example of this would be a hand spreader. How many of you have ever used a hand spreader where you can actually move the dial at the bottom and you can adjust the flow of those granules coming out? You may have done this with fertilizer in your yard, you may have done that with grass seed, but that just gives you a small idea of how you can regulate that flow with granular operations. Now, as you're seeing here, we've got a big broadcast application on a farm. That's totally different because there we're putting out a ton of product, but we still have to remember, especially when it comes to calibration, how quickly we travel and how big we have the opening at the broadcast at the bottom. That's going to dictate how much of the product we put out as we move along. More with granular applicators. Band applicators use hoses or tubes with deflectors on the bottom. Broadcast applicators use a system of tubes and deflectors or a spinner to spread the granules. The application rate is affected by ground speed, granular size, shape and density, field terrain, and even relative humidity and air temperature. And I hope some of you paid attention when you were in science and chemistry classes. It almost amazes me sometimes how many things we learned in grade school that we use later in life. Again, this application rate when it comes to granular applicators is going to be affected by ground speed, how fast you're traveling, the granule size, the shape, and the density, that field terrain, and even relative humidity and air temperature. Each one of these things has an impact on that application. So as you're going through things like calibration, all of these are going to be factors. And the goal of this is we're trying to applicate per the label rates. And we just have to remember there's so many different factors in that each time we do an application, it can be a little different. When multiple band applicators are used, each individual unit must be calibrated with the specific material to be applied to ensure accurate application. Rotary and drop spreaders are two common types of granular applicators. Rotary spreaders distribute the granules to the front and sides of the spreader, usually by means of a spinning disc or fan. In a drop spreader, an adjustable sliding gate opens holes in the bottom of the hopper. Granules flow out by gravity feed. Drop spreaders are superior to rotary spreaders when more precise placement of pesticide is desired. Let's talk a little bit more about rotary versus drop spreaders. Now, drop spreaders offer precise application in narrow areas. These will be good to use when you need a narrow band application. These are going to be ideal for lawns with landscaping, mulch beds or planting beds, narrow strips, and issues with tight turns. These spreaders help prevent waste by allowing the applicator to hit more precise areas and not hit areas like sidewalks and driveways. And I think this is going to be more of something you would use in a residential application as we're describing here. You really need to think about, before you pick a spreader, what type of treating area you're going to be dealing with. If we've got these mulch and planting beds, if we've got narrow strips, tight turns around trees and different landscaping, obviously drop spreaders are great. Also, we don't want to get granules all over sidewalks and driveways and maybe even play areas or sandboxes. We don't want to go through with a rotary type of spreader and just granulate everywhere. And these drop spreaders allow us to hit those more narrow areas and make sure that we don't applicate in areas we don't want to. And as you can imagine, this can save you a lot of time and trouble. Outside of just saving money from over application, this can keep you out of situations where people are unhappy because they see those granules in areas that are not the target area where you wanted to put them out. On the other hand, when it comes to rotary spreaders, these are more suited for application in large areas. An area like an open field in a park or other large area like this could be a great time to select a rotary spreader. Anytime you have a large lawn area with few obstacles, these could work well. The biggest benefit rotary spreaders provide is saving time by covering large areas more quickly. And once again, if we don't have all those obstacles and we can just go, we want to treat a large area really quickly. We're not worried about dealing with like driveways, sidewalks, areas where people are going to walk. Then we would definitely want to use a rotary spreader because time would be of the essence in a large area like this. Let's talk about some other application equipment. Additional types of application equipment include rubs, walk-through sprayers, and dripping vats to control pests on animals, bait dispensers to control rodents, insects, and predators, foggers for indoor pest control and some outdoor insect control, chemigation systems for greenhouses and field crops, and dusters for small-scale disease and insect control. On this slide, you're seeing some images of those other types of treatments. On the top left, you're seeing cattle walk through a sprayer. Top center, you're seeing a cattle dip chute. In the top right, you're seeing cattle rubs. In the bottom left, you're seeing field chemigation. In the bottom center, you're seeing a bulb duster. And on the bottom right, you're seeing a sheep dip. Let's talk about something people seem to ask all the time. Why calibrate? The purpose of calibration is to ensure that your equipment is applying the correct amount of pesticide material uniformly over a given area. Too little pesticide may fail to control the target pest. Too much pesticide is illegal and can result in damage to the treated plant, animal, or surface, can produce illegal residues on treated crops and animals, and can cause adverse effects to the environment and non-target organisms. Calibration. Super important. We need to make sure our equipment is calibrated. Once again, why do pesticide treatments fail? Sometimes it's because your equipment's not calibrated. If I'm not putting out enough of the product that's been tested and approved by the EPA, am I really going to control that insect? Am I really going to control that weed? Probably not. Now, we may be putting out too much as well. If we're putting out too much of the product because we've got too high a pressure on a sprayer or because we're walking too slowly, then we know we've got another issue, we've over-applicated, and there can be all types of issues with that, with impacts to the environment or things like burning up lawns because we get out too much of a fertilizer. Either way, let's make sure we limit these adverse effects on the environment and non-target organisms. Let's talk about that equipment calibration. Calibration is the process of measuring and adjusting the amount of pesticide your equipment applies or delivers to a specific area. The purpose of calibration is to ensure that your equipment is applying the correct amount of material uniformly over a given area. It's important that we all understand that equipment is made to be adjustable. Charts or tables assist the operator in adjusting the settings. These recommended settings, however, are only approximate and may not appropriate for all situations. Therefore, your equipment must be calibrated periodically. How often depends on the type of equipment and the frequency of use. The application rate of a sprayer is affected by travel speed, nozzle size, and sprayer pressure. Even with the widespread use of electronics to monitor and control the pesticide application, a thorough sprayer calibration procedure is essential to avoid misapplication. Equipment can be calibrated by making a trial run on some pre-measured area and measuring the output. For example, using a handheld sprayer, spray a pre-measured test area with water using the same pressure and techniques, i.e., travel speed and equipment, you would use when applying the pesticide. After spraying the test area, determine how much water was used. This volume can then be used to calculate the total amount of water and pesticide needed to cover the intended application area. When calibrating a boom sprayer, there are 3 variables that affect the amount of spray material applied per area of measurement, i.e. gallons per acre or gallons per 1,000 square feet. Number 1 is going to be the nozzle flow rate. Number 2 is going to be the ground speed of the sprayer. Number 3 is going to be the width sprayed per nozzle. To calibrate and operate a sprayer properly, it is important to understand how each of these variables affect sprayer output. The nozzle flow rate varies according to the size of the orifice, the nozzle pressure, and the density of the spray liquid. The spray application rate varies inversely with the ground speed. Doubling the ground speed of the sprayer reduces the gallons of spray applied per acre by 1/2. Likewise, doubling the effective width sprayed per nozzle decreases the amount by 1/2. Now, in my mind, because I've done this since 1999, some of these things seem pretty simple to me, but I can tell you when I first started, they really didn't. When I look at number 1, as we talked about our nozzle flow rate, the flow coming out of the nozzles has a big impact on calibration. So if those nozzles are flowing at a higher rate, we're putting out more of the product if we're moving the same speed. At the end of the day, one of the biggest problems is going to be clogging in the nozzles, like pesticide buildup. Well, if you think about it, if you have pesticide buildup in your nozzles, of course you're not putting out as much of the product, so that nozzle flow rate's going to make a big difference. Now, we talked about this earlier. There's a lot of different types of nozzles you can use, so that's a whole nother ballgame. You have to understand the flow rate of each individual nozzle to understand how much of the product you're going to put out. Now, as far as ground speed of the sprayer goes, there's another one. If we're moving 1 mile an hour or 2 mile an hour or 3 miles an hour, whatever the case is, if we start moving faster, we're going to be putting out less. We talked about that down here at the bottom of our last slide. Obviously, if we double our ground speed, the sprayer reduces the number of gallons sprayed applied per acre by 1/2. The time invested in calibrating your equipment is time well spent. Accurate calibration to determine the application volume under your operating conditions is important for cost, efficiency, and safety. Without properly calibrating the sprayer to deliver the correct application volume, you will not be able to apply the pesticide at the proper rate to control the pest. Your category-specific manual will explain in detail how to calibrate your application equipment. Think about what I just said. That time you invest in calibrating your equipment is definitely time well spent. Again, this is going to be important for cost, efficiency, and safety. So every company out there is trying to keep cost under control. Obviously, we need to be efficient. We need to make sure we're applying the right amount of product at the right time, at the right place, and safety. Anytime we're not calibrated with our equipment, we're putting our safety, the environment's safety, and other people around us at risk. Let's take a look at calculating area in square feet. Alright, now that I got my quick Go Gators plug in there, when we talk about calculations, it's important to know calculating areas is going to be a huge thing when it comes to handling pesticides. You're going to need to know how to calculate several different types of areas based on their shape and size. For instance, we're going to be looking at a rectangular area on this slide. Now for calculating area, for precise application, you need to know the size of the area to be treated. The following examples show how to determine the size of rectangular, triangular, and circular areas. First, when we're looking at rectangular areas, you want to apply a pesticide to an area that measures 1,320 feet by 120 feet. What is the area in square feet and in acres? Now, before we even set up this math problem, you need to understand that 1 acre is equal to 43,560 square feet. That's a good number for you to remember. As you can see at the bottom here, we've got the length at 1,320 feet. We've got the width on the right at 120 feet. In our calculation, area is going to equal length times width. So first in our calculation, we're going to take the length, 1,320 feet, and times it by the width, 120 feet. This is going to give us a total of 158,400 square feet. Now we want to figure out how much this is in acres because a lot of our product labels are going to deal in acres. The area in acres is going to be the total square feet divided by the square footage of an acre. So in this case, it's going to be 158,400 square feet divided by 43,560 square feet, equaling a total of 3.6 acres. Now another common type of shape you might deal with when figuring out how much pesticide to apply is going to be a triangular area. Let's say you are applying a pesticide to a triangular area that has a base of 325 feet and a height of 150 feet. What is the area? Area in this case is going to equal base times height divided by 2. Just like we did on the rectangle, we need to figure out our area in square feet first. We're going to take that base, the 325 feet, times the height, 150 feet, for a total of 24,375 square feet. Again, trying to figure out the area in acres, we're going to take our 24,375 square feet, we're going to divide it by the total square footage of an acre, 43,560 square feet. Our total is going to be 0.6 acres or 6/10 of 1 acre. And then there's everybody's favorite, circular areas. I can tell you, all these calculations can be tough for a lot of people, especially that are new in the industry. Circular areas are the ones I see people struggle with the most. So when we look at circular areas, you need to know, if you have a circular area that has a 90-foot diameter, the radius, or R, is 45 feet. I came up with this number of 45 feet because anytime you know the diameter or the measurement across a circle, all you have to do is divide it by 2 to get the radius. Again, in this case, 90 feet of diameter divided by 2 is 45 feet radius. Now, another important factor in figuring out the area of a circle is you need to know the area equals 3.14 or pi. You may remember this from school. Pi is always going to equal 3.14. Now we're ready to calculate our square feet. When we look at the area in square feet, we're going to take pi, or 3.14, times 4/5, or the radius of the circle. This is going to equal 6,358.5 square feet. Our final calculation, looking at this circular area, is going to be calculating the area in acres. We're going to take what we have in square feet, 6,358.5 square feet, and divide it by the square footage in an acre, which again is 43,560 square feet, for a total of 0.15 acres, or 15/100ths of 1 acre. Let's look at calculating the application rate. Use the volume from your calibration test area to determine the amount of pesticide product and total spray mixture needed for your application area. First, convert your calibrated rate to one based on the area units found on the label. For example, assume that when you calibrated the sprayer, it delivered 2 gallons of water over a 250 square foot test area. Your application area measures 1,000 square feet, i.e., 4 times the test area. Therefore, you need to use 8 gallons of spray mixture to cover 1,000 square feet, multiplying 2 gallons of water by 4. And I hope everybody understands this. So many people don't understand how to do this in the field, and they definitely failed this question on core exams. Remember, you calibrated the sprayer. It delivered 2 gallons of water over a 250 square foot test area. Your application area measures 1,000 square feet. This is 4 times the test area. So we already know what the test area was in square feet, and we know the application area is 4 times the amount of that square footage. Therefore, making it really simple, you need 8 gallons of spray mixture to cover 1,000 square feet. One last time, that 2 gallons of water was put out over 250 square feet. Now, we understand our application area measures 1,000 square feet. Now we need to understand that 250 square feet of calibration area has to be figured into our total treatment area of 1,000 square feet. So keep in mind, it could be a simple problem like this. 250 square feet times X equals 1,000 square feet. In this case, 250 times 4 would equal 1,000 square feet. So if I took 250 and I added it 4 times, 250 plus 250 plus 250 plus 250, we come up with that 1,000 square feet. But obviously in our minds we can figure this out. 250 times 4 equals that 1,000 square feet. So you need to remember the number 4 because that's going to be useful in understanding the total number of gallons we need. As we talked about before, we're putting out 2 gallons per 250 square feet. Now we understand 1,000 square feet of application area is 4 times that 250 square feet of calibration area we talked about. We have a simple solution here. That 2 gallons we put out over 250 square feet gets times by 4 because now we're treating 1,000 square feet for a total of 8 gallons needed. I hope this helps out because so many people fail exams or don't applicate right because of not understanding this, and it's really simple math. You just have to make sure you keep your numbers, like if you have to write them on a scratch paper or whatever it is, you have to break this down into smaller problems to get you to the bigger answer. We're also going to need to check the pesticide label to determine the amount of pesticide to add to the spray mixture. For example, if the label recommends adding 4 ounces of a liquid pesticide product to give a desired finished spray mixture of 1 gallon, you would add 4 ounces of product to 124 ounces of water. 1 gallon equals 128 fluid ounces. If you needed to apply 8 gallons of spray mixture to cover 1,000 square feet, then you must add 32 ounces, 8 times 4 ounces, of pesticide product to 7.75 gallons of water. If the tank capacity of the sprayer is 4 gallons, you need to fill up the tank twice, using 16 fluid ounces of product each time. I want you to understand one thing further on this slide before we talk about it a little more. We're talking about the area that says, for example, if the label recommends adding 4 ounces of a liquid pesticide product to give you a desired finished spray mixture of 1 gallon, you would add 4 ounces of product to 124 ounces of water. Just keep in mind, what we're looking for on this label is a desired finished spray mixture. If it doesn't say a desired finished spray mixture, we might just add 128 ounces of water and 4 ounces of the product. You have to really watch your labels and understand what they're asking. This is why I want to teach you something a little bit different based on the wording of this label. Remember, there are 128 ounces in a gallon. This is important to effectively calculate amount of pesticide needed. And this is going to be a very important one. Secondly, if a product calls for a mixture rate of 4 ounces to 1 gallon of water, you would only use 124 ounces of water because the total amount of pesticide in water would equal 128 ounces. And I think a lot of pest control people don't understand that. I've seen this a ton of times on core exams, and even myself, for the longest time, I struggled. You need to understand the amount of pesticide to be mixed with that gallon of water, and you need to reduce the number of ounces of water in that mixture by the number of ounces of product you're mixing with that water. In the scenario we just discussed with you, you need 128 ounces total. So again, we take 128 ounces minus 4 ounces of the pesticide mixture, which would give us 124 ounces of water. This is a great principle to remember. Now your mixture rates will be correct when you're mixing in the field, and I can tell you this will come in very handy when taking these core exams. You also need to understand labels vary in how they recommend pesticide application rates. Some examples include ounces of product per 1,000 square feet, pints, quarts, gallons per 100 gallons, pounds of product per acre, or percent product in the tank. Further, on calculating the application rate, you determine from a calibration test that your boom sprayer delivered 10 gallons of water over 1/4 acre, 0.25 acre test area. You need to apply a pesticide product to a 10-acre field, 43,560 square feet equaling 1 acre. The pesticide label recommends that 4 ounces of liquid product be added to give a desired finished spray mixture of 1 gallon. There are 128 fluid ounces in 1 gallon. How much spray volume and how much product are needed in this scenario? We're going to break this down over 3 steps. How much spray mixture is needed for the 10-acre application area? Always use information from the calibration test. In this example, 10 gallons of water was used over a 0.25 or 1/4 acre calibration test area. We've got some constants to work with. We understand that when we were doing our calibration tests, 10 gallons of water was used over a 0.25 or 1/4 acre calibration test area. I want you to understand how I set up this algebraic equation. On the left side, I put the 10 gallons with a line underneath it and the 0.25 or 1/4 acre underneath that. This once again denotes that we used 10 gallons of water over that 1/4 acre area when we were doing our calibration test. Now, as you can see on the right side of the equation, what we're trying to figure out is y. As you remember from algebra probably, y is like the factor you're trying to figure out. So in this case, we need to understand what y is going to be, which is going to be the number of gallons required to treat the 10-acre area we just discussed above. The final part of our algebraic equation is going to be putting the 10 acres at the bottom underneath the number of gallons we're looking for underneath our line. We're going to put the 10 acres at the bottom because this is going to be another constant. And in this case, of course, the 10 acres denotes the actual application area we're going to be treating. Alright, while we're having fun, let's keep working our algebraic equation. Once again, we need to figure out what y is. So we know we have a 10-acre application area. Now, we're going to take 10 gallons and we're going to times it by 10 acres. So we're going to use cross multiplication as you're seeing here. And then we're going to divide that number by 0.25. So in essence, as I'm showing you here on a calculator, we're going to do the 10 gallons times 10 acres divided by 0.25. And this is going to show us we need 400 gallons of spray mixture. And now we've finished step 1 of our equation. We only have 2 more steps to go. Now that we've figured out we need 400 gallons of finished spray mixture to treat our 10-acre application area, we need to know how much pesticide product is needed to make 400 gallons of spray mixture. Let's use the label rate of 4 ounces product per 1 gallon of spray. Keeping in mind, this is not a label that's telling us to reduce the amount of water we use by the number of ounces added to the product, so we're going to add the full 4 ounces of product to 1 gallon of water. Now, we're going to take our 400 gallon spray mixture, times it by 4 ounces of liquid pesticide product per gallon. This will equal 1,600 ounces of product needed. This will conclude step 2 of our process. Now we're ready to move on to step 3. In step 3, we're going to figure out how many gallons of product are needed. Remember, 128 ounces equals 1 gallon. We're now going to take the 1,600 ounces of product we figured out in step 2, and we're going to divide it by 128 ounces. So we finally have figured out, to treat 10 acres, you will need a total final spray mix of 400 gallons that includes 12.5 gallons of the concentrated product. This gives you the final answer to our question. Let's talk about techniques to minimize drift. Application techniques and equipment greatly influence the amount of spray drift that occurs. Off-target movement is affected by the type of nozzle, nozzle orifice size, sprayer pressure, and the height or distance of the nozzles from the target. It is important to review the pesticide label for specific information on drift reduction techniques or requirements. You must also check weather conditions such as air stability, wind direction, and speed at the time and place of the application, and follow all weather-related restrictions on the label. Of the many nozzle types available for applying pesticides, several are specifically designed to reduce drift. Select nozzles to give the largest droplet size that provides adequate coverage at the intended application volume and pressure. In addition to the size of the nozzle orifice, some new nozzle designs help reduce drift by incorporating air into the spray to form an air-fluid mix. These air introduction nozzles, known as Venturi nozzles, form a larger spray droplet, produce fewer fine particles, and provide energy to help transport the droplets to the target. These nozzles, however, require higher spray pressures, 40 to 100 pounds per square inch, to be effective. Even at these higher pressures, Venturi nozzles still dramatically reduce the likelihood of drift. Operating pressure also affects the droplet size and output volume of the sprayer. Doubling the pressure does not double the flow rate. To double the flow rate, you must increase the pressure 4 times. Pressure cannot be used to make major changes in application rate, but it can be used to correct minor changes due to nozzle wear. To obtain a uniform spray pattern and to minimize drift, keep the operating pressure within the recommended range for each nozzle tip. Exceeding the recommended pressure range often results in more drift potential. To maintain a proper spray pattern, adjust nozzles according to the manufacturer's recommendations on nozzle spacing and spray angle. Applications made with an electronic rate controller are subject to pressure changes as the operating speed varies. Even though the purpose of the rate controller is to help make application volumes more uniform as sprayer speed changes, major adjustments in speed can affect pressure. For example, doubling the speed will result in a 4-fold pressure increase in an attempt to maintain the correct volume. The increased pressure without changing nozzle orifice size will dramatically increase the potential for drift. Likewise, reduced speed can lower the pressure, which may affect coverage and ultimately pattern quality. Spray height or distance from the target site is also an important factor in reducing drift. The closer the boom or spray nozzle is to the ground or target site, the less chance for drift. However, watch for pattern uniformity. We need to remember to check conditions. Use an anemometer and compass to check wind speeds and direction. Spraying is best done when there is some wind, and the operator can be sure that the wind direction is stabilized. Low drift nozzles allow for spraying in faster wind speeds. Avoid night spraying under conditions of temperature inversion when air near the ground is cooler than the air above it, causing poor spray dispersal. It's important to note that temperature and relative humidity, RH, affect how quickly spray droplets evaporate. Droplets evaporate more quickly at higher temperatures and lower RH, making them more prone to drift. Remember, coarse sprays are less prone to drift than fine sprays. Use low drift nozzles. Conventional fan nozzles or hollow cone nozzles are usually too drift prone and don't provide an efficacy advantage. A larger nozzle opening will produce a coarser spray. We can also use high carrier volumes to reduce drift. Most herbicides work well between 50 and 200 liters per hectare. Use of higher carrier volumes is a very effective way of reducing drift for two reasons. First, if travel speed is maintained, a larger nozzle is used to apply the higher volumes. This results in a coarser, less drift-prone spray. Second, the spray solution is more dilute at the higher volume. Drift will contain less active ingredient and have less potential to cause damage. Another way of reducing drift is to adjust travel speed and boom height. The relationship between travel speed and boom height is very important. Generally, a lower travel speed and lower boom height significantly reduces the potential for spray drift. Faster travel speeds cause increased air shear on the spray sheet, which increases its breakup and produces a finer spray which is more prone to drift. Spray stays aloft longer at faster speeds because it is swept back due to wind resistance. Higher boom heights are usually required at higher travel speeds due to uneven terrain. Another way to minimize drift is to use shrouds. Shrouds can reduce drift by up to 75% in some cases, although not all booms can accommodate them. Cone shrouds are an alternative, which have also been shown to reduce drift by up to 50% and allow more ground clearance for suspended booms. They won't contaminate susceptible crops with spray residue on the shielding material. Shrouds become less effective at higher boom heights and faster travel speeds. Another way to limit drift is through air assist. Air assist uses an airstream to increase the speed that the spray is carried down toward the target. This should reduce the time it hangs in the air, exposed to wind. The direction and velocity of the air blast must be matched with atmospheric and crop canopy conditions. Too strong an air blast into a small crop canopy like seedling wheat, and the spray can bounce off the ground and return up in the airstream, increasing drift. Air assist must be adjustable to be useful and requires an experienced operator. Know your product and what's downwind. Know the active ingredient and the likely impact of spray drift on anything downwind. Sulfonylurea herbicides, phenoxys, and glyphosate are very potent and can damage susceptible plants at very small doses. Most other herbicides are less active and may have less effect on plants. Many insecticides and fungicides, however, are very harmful to aquatic or avian species, and drift or runoff into water must be avoided. Another thing you need to think about with drift is sensitive areas. Always make sure the wind is blowing away from sensitive areas. Buffer zones should be used to reduce the impact of spray. Buffer zones are the downwind distance from the edge of the spray swath to the upwind side of a sensitive area. Product labels list recommended buffer zones from sensitive ecological areas. To maintain uniformity, most nozzle types require some amount of overlap. Maintaining a 1-to-1 ratio of boom height above the target to the nozzle spacing on the boom will satisfy most overlap requirements. For air blasters, reduce drift by minimizing spraying over the canopy top. Use the minimum airspeed that will still give good penetration into the canopy and consider the use of tower sprayers. Another way to minimize drift is to use drift control additives. Tests indicate that the use of some additives reduces downwind drift deposits by 50 to 80%. Drift control additives are a specific type of chemical adjuvant. They must be mixed and applied according to the label directions to be effective. Research, however, has shown that some products intended to reduce drift in fact increase drift potential. This research also shows that although some of these additives dramatically increase droplet size, they may also reduce coverage and lessen the overall effectiveness of the pesticide. Thoroughly evaluate drift control additives before using them. Using approved application techniques and adopting new technologies designed to reduce spray drift can improve the performance of spray mixes, benefit the environment, and be more cost-effective. Any one practice used alone may not sufficiently reduce drift. Summary: to choose the most suitable pesticide application method, you must consider factors such as the target site, target pest, and which pesticide formulation you intend to use. Further, you must wear all PPE specified on the label for a specific task and, when required, use closed mixing and loading systems, enclosed cabs, and pesticide containment systems. Even if not required, using these safety systems will help protect humans and the environment from exposure to pesticide. Let's look at Chapter 12 of the Core Pesticide Training Manual, Professional Conduct. After studying this chapter, you should know how to recognize when a certified applicator must be present during an application from information provided on the label or by regulations. Understand the importance of keeping records of pesticide training for uncertified individuals. Assure that an uncertified individual that you supervise can understand and follow application procedures. Understand the importance of providing detailed guidance for pesticide applications that you supervise. Know your responsibilities in supervising uncertified individuals. Understand the importance of explaining appropriate federal and state laws and regulations to uncertified individuals that you supervise. Know how to communicate with customers and explain realistic expectations of pesticide applications. Know how to describe notification procedures for customers and neighbors prior to applications, e.g., chemical sensitivity registries, restricted entry instructions, post-application requirements. Know how to provide labels and material safety data sheets upon request. Know how to provide notification and signage required by laws and regulations for the durations of restrictions. Know how to address or refer public inquiries about pest and pesticide applications. I just want to take a moment to mention that professional conduct is a huge part of your job as a pesticide applicator. It doesn't matter if you're a supervisor or a technician, the way you conduct yourself is very important. And this is also going to be in communication. If you're a certified applicator or certified operator, how you communicate with your employees is going to be very important. Also, any certified operator, certified applicator, or even technicians are also going to need to understand how important it is on how you communicate with customers. You've got to set the expectations. You have to be the professional. If you don't set the expectations with customers on what they can expect, you're going to have a lot of problems throughout your pesticide career. So make sure you work on a high level of professionalism, you understand your products, and you understand the communication you need with customers. Webster's Dictionary defines professionalism as the conduct, aims, or qualities that characterize or mark a profession or a professional person. Many factors have an influence on the professional conduct of pesticide applicators. It is important that certified pesticide applicators understand the rules and regulations on supervising uncertified employees and how to train employees in proper pest control techniques. And I wanted to stop here for just a moment and talk about becoming a certified applicator. Some states will also call this a certified operator, so don't be confused between the two. They typically are going to mean the same thing. But the bottom line is, before you can become a certified applicator, you're typically going to need some experience. Now, I've seen this as short as 30 days in some states, but typically it's anywhere between 1 and 3 years. So you need to understand your specific state laws on this, because you're usually going to have to take state exams that are going to qualify you to become a certified applicator. You also need to understand, as a certified applicator, you're taking on a lot of responsibility. You're basically going to be in charge of pest control activities a lot of times in this position, so everybody's going to be looking up to you. So make sure you understand the federal laws, the state laws, and make sure you're ready to lead a team of people to go out and do the right things every day. Implementing proper training and pesticide security measures assists the pesticide application business in establishing and maintaining a professional image. People are quite concerned about the safety and health effects associated with pesticides. Therefore, it is extremely important to be able to communicate with customers effectively, accurately, and in a professional manner about the nature of the pest problem, the chemical and non-chemical means to prevent and control pests, and the risk involved if a pesticide is used. And now we are going to get to the topic of supervision. Unless otherwise prescribed by its labeling, a pesticide shall be considered to be applied under the direct supervision of a certified applicator if it is applied by a competent person acting under the instructions and control of a certified applicator who is available if and when needed, even though such certified applicator is not physically present at the time and the place the pesticide is applied. This comes from FIFRA, Section 2E4. This section in FIFRA establishes the minimum federal standard for direct supervision of uncertified individuals. Some states require a certified applicator to be physically present at the application site whenever an uncertified individual applies a restricted use pesticide. Some states require the certified applicator to perform the application, while other states require the certified applicator to be present during the application of any pesticide, i.e., both restricted use and unclassified use. The supervising certified applicator is responsible for the actions of the uncertified person throughout the entire application process, i.e., mixing, application cleanup, and disposal. In some cases, product labels may restrict the use of certain pesticides to certified applicators only. In such instances, an uncertified applicator may assist the certified person, but the actual application must be performed by the person certified in the appropriate pest control category. Just remember this, that supervising certified applicator is the one going to be responsible for those actions of the uncertified person, so just make sure as a certified applicator you're training your people correctly and you're also monitoring their applications to make sure they're following the label and the law. The phrase, under the direct supervision of, means the act or process whereby the handling and application of a pesticide is made by a competent person, acting under the instructions and control of a certified applicator. The key words are competent person. In this context, competency is defined as being properly qualified to perform functions associated with a pesticide application. Now, when we think about a properly qualified, competent person, you need to know it is essential for supervisors to prepare and train each uncertified person to independently handle and apply pesticides in a reasonable manner. Uncertified applicators need to be every bit as professional as their certified colleagues. It is important that uncertified persons understand basic information such as federal and state pesticide laws and regulations, security and emergency procedures in the event of an incident, the importance of carefully following all label instructions, knowledge about the pesticides and application equipment to be used and the pests to be controlled, the proper use of all personal protective equipment, the need to keep accurate and precise application records, the need to communicate regularly with the certified supervisor. Proper supervision is not merely a single instructional event, but rather a continuing education process. Maintaining good training records helps to assure management that training throughout the employee's career is timely and relevant. Supervision requires continual interaction between the supervisor and the uncertified person. And let's just say at this point, you have to remember these training records are really important. They're going to help you comply with federal and state laws, but also the employee's career is tied to the supervision. So make sure that interaction is continual between that certified supervisor and the uncertified person. That's going to be very important for that uncertified person to grow and get the knowledge and skills they need to go further in their career. Let's talk about pesticide security and supervision. Pesticide security has the mission of protecting people, facilities, and the environment from harm. In pesticide certification and training, pesticide security is about allowing access to pesticides only by competent persons. Pesticide security is important for all pesticide distributors, retailers, and end users, including uncertified individuals. Supervisors, as well as those persons being supervised, must be knowledgeable about security procedures. And I have to tell each and every one of you, talking about security of pesticides is going to be a really big deal throughout your career, and those of you taking exams in the core categories are going to see questions about these security procedures. You're also going to see things like this where you need to develop a written security plan that includes well-defined communication procedures between the supervisor and the applicator. Given the ability of today's modern communication technologies, such as cell phones, pagers, and remote internet access, maintaining frequent contact between the certified applicator and the uncertified staff need not be a problem. Such technologies permit immediate contact. No pesticide applicator, certified or uncertified, should be without such communication devices today. So we understand we're going to need a written security plan that includes well-defined communication, and that's going to be between the supervisor and the applicator, as we talked about here. Obviously, everybody has a cell phone nowadays, so just make sure you're staying in touch with each other. As we keep talking about, that certified supervisor and the uncertified applicators need to make sure they stay in touch, because whether we're dealing with security or anything to do with the applications themselves, communication is going to be the key. And as you can see in the image on the screen, we're showing the certified supervisor on the left and the uncertified person on the right. You can see how they have a smile on their face. The point we're making here is make sure you have good and open communication. Make sure you treat each other with respect, and make sure that you don't give anybody the impression that they can't call you. If you get to the point where there's animosity between the supervisor and the uncertified person, it's only going to lead to issues out there in the field. Let's talk about public and customer communications. The importance of professionalism to a successful business cannot be overstated. A professional person or company must strive for excellence. Professionalism deals not only with how you and your equipment look, but also with how you deal with other employees, customers, the public, and in some cases the media. This can all be summed up as your professional image. We've been talking a lot about relationships here and how you conduct yourself. Just remember, how you look, how you dress is a really big part of this. How your equipment looks is a big part of this. If you go out in clothes that look unkept, look unwashed, or you're wearing something with stains all over it, it's not going to be a good image. At the same point, if your equipment has pesticides all over it, maybe you were pouring some pesticide concentrate in a tank and some of it splashed out and it dried up on the outside of the tank, that's not going to look good to the public. So just make sure that you're presenting yourself in the correct way, and make sure when dealing with other employees, customers, and even the public and the media, make sure you have your professional image on. If you don't, it's only going to lead to a bad name for you and a bad reputation for the company itself. This professionalism includes continuing education, keeping up with current pesticide regulations, knowing enough to ask for outside help when you do not have all the answers, knowing the safety and environmental aspects of the job, and taking the initiative to communicate with your customers. What the public hears from the receptionist, technician, and pesticide applicator helps form their opinion of the company as much as do the final results. And this just kind of sums up professionalism. You got to keep up with the continuing education, you got to know when to ask for help, and you have to communicate well with the public because they are judging you on your communication and your knowledge and the whole 9 yards of how you interact with them as a whole. Pesticide applicators must never give their customers or other members of the public the impression the pesticide products they use are safe, or imply the products or services they offer are safer than those used by other companies. Creating a professional image begins with the vocabulary used by employees. It is important to use terminology about pests and pesticides the public can understand. Never use phrases such as environmentally friendly, safe for children and pets, safer, and harmless when referring to pesticide products or to the services offered by a pesticide applicator. Just keep this in mind, especially those of you that are taking core exams. You're not ever going to be able to say a product is safe because the reality is anything that ends in the word side does mean death. CIDE, side, that suffix does mean death. So the reality is the products are not going to be safe. You just have to come up with good terminology for your customers to understand. We're using these products in the safest way possible. We're doing our best to protect you and your family, but you can't use these terms as we just talked about here because that would be going against federal law. Also, avoid using the terms organic, natural, or least toxic because these terms lack a common definition and are likely to confuse your customers. Pesticide applicators must not refer to EPA and state registered products as EPA approved or state approved. Such references can give the public the impression no risk are associated with the use of the pesticide products, and these agencies endorse, approve, or recommend the use of particular products. Don't say, "We only use EPA approved products." Even though it's true, it is still misleading. Acceptable terminology may include describing the product as reduced risk and/or less toxic. Explain to the customer why the risk is reduced when compared with the use of a higher toxicity product. Also explain whether the product requires more applications to be as effective. Provide customers information packets that explain the risk associated with the pesticide. This may include additional information from labels or MSDS, now called SDS, or safety data sheets. Always communicate to customers the risk associated with a pesticide and provide them with additional information. It is important for pesticide applicators and pest management specialists to spend time with each customer explaining what needs to be done and why. Show customers how environmental, cultural, and physical factors can contribute to ongoing pest problems. Once again, it's your job as a pest management specialist to set the expectations with customers while also educating them. So as we can see here, the guy's talking about the use of a crack and crevice tool on a vacuum cleaner. The point being made is they only know the expectations you set and how you educate them on what you're going to be doing and why you're going to be doing it. For example, moisture, humidity, planting site, sanitation, improper plant selection, and ineffective barriers all may play a role in pest outbreaks. Do not merely tell the customer what you are spraying for, but rather show the customer the problems. Defining the what and why includes explaining product selection, how it is used, and anticipated results. As you can see here at the bottom right, explain how plants growing against the structure and moisture from watering can give ants harborage and access. One other thought on this slide. As you can see here, we have those plants growing against the structure. This is giving a superhighway for ants to enter the structure, especially when we consider not only do they have the plant to crawl up, but obviously it's being watered, so there's always a moisture source in that area. The reality is, if we don't explain and set the expectations with the homeowner that this needs to be corrected, we're never going to effectively solve that ant problem. And even if we're never going to effectively solve that ant problem because we're not taking a look and doing what we need to treat the source itself. Be factual and, above all, do not exaggerate the results your customer can expect from the treatment. Inform the customer about any post-application label instructions, such as re-entry restrictions, watering in a pesticide, or livestock grazing or feeding prohibitions, whether in the field, the garden, or a structure. Some states have mandatory pre-application notification requirements for customers or neighbors. These include chemical hypersensitivity registries currently enforced in about a dozen states. Be sure to let your customers know if the neighbors have requested notification and if there are any concerns or objections involving the use of pesticides. At a minimum, prior notification to concerned individuals shall include 1. Date and address of the scheduled application. 2. Name and telephone number of the applicator. 3. The applicator's certification, license number, where applicable. State laws and regulations may differ from these minimum notification requirements. Therefore, pesticide applicators must know what their state-specific notification requirements are before making an application. So just keep in mind, any of you that are dealing with people on the pesticide notification registry, which is what I call it, each state might call it something a little bit different, you're just going to have to make sure you understand who has to be notified, how they have to be notified, and when they have to be notified. If not, this can cause a major problem for you, especially if one of these people see you doing an application and they've not been notified. I'm going to say your state's probably going to come down on you pretty hard at that point. I'm going to say the state's probably going to be having a conversation with you at that point. Regulations in some states may require you to provide copies of labels and SDS at time of application. Such requirements usually involve applications around residential, school, and recreational property, but rarely agricultural areas. States and other governmental entities may also require posting of the treated site immediately following a pesticide application, especially when the application is made to residential and golf course turf, landscape areas, ornamental plants, school property, or public access areas, or around the perimeter of structures. A number of states now have school integrated pest management (IPM) programs that require notification of school staff members and parents and posting of treated areas. Even in states where these requirements do not exist, companies often post notices at entry points to recently treated areas. This usually involves placing a small plastic flag or sign in a conspicuous place to alert people to avoid the treated area, at least until the spray is dried thoroughly. Check with your state, tribe, territory, or other pesticide regulatory agency to make sure you are in compliance with any posting requirements. To maintain good customer and public communications, consider keeping more detailed records than required by federal and state laws. Records can prove invaluable as documentation in the event of a complaint or a lawsuit against your business. Pesticide records provide all the necessary information about the pesticides and how they were actually applied, thus protecting the applicator from what may be false accusations. Additional information could include weather, nozzle sizes, spray pressures, ground speed, calibration, or any other special precautions that may have been used or taken. Records can also help determine which pesticide treatments work, which treatments do not work, and why. Record keeping is also a major tool of IPM by documenting pest sightings and population levels, pest control techniques used, and overall environmental conditions. Good records enable an applicator to make more informed pest control decisions. If medical treatment for a pesticide injury is required for humans or animals, records can provide information necessary to the medical staff for diagnosis and treatment. Good records can also document the steps that were taken to protect farm workers and the environment from pesticides. Records may also be used to respond to the public's concern regarding pesticide use. How to answer customer questions. Today, customers and other concerned individuals are likely to ask the pesticide applicator, the sales representative, or the service technician about the products that will be used to manage their pest problems. They may ask about possible effects on children, pets, property, the environment, and themselves. How you answer these questions can determine whether you have a satisfied customer. Preparing yourself and your staff to answer consumer concerns is the professional approach. A good way to familiarize every pesticide applicator and technician in the company with typical questions and answers is to discuss these during company training sessions. Role-playing by the staff members can help reinforce correct and responsible responses. If requested by the customer or anyone else inquiring about pesticides, provide web addresses and 800 phone numbers for pesticide emergencies and for pesticide information. For emergencies, contact the National Poison Control Center at 1-800-222-1222. For pesticide information, contact the National Pesticide Information Center, NPIC, at 1-800-858-7378 or at the website you see on the screen. Also, when requested by your customer or other concerned individuals, be prepared to provide the trade and common names of the pesticides and copies of the product labels and MSDS, SDS sheets. Your professional image. It takes work to achieve and maintain a professional image. As a representative of your pest management company, seek to reinforce a positive company image. Remember, your work actions reflect on your company and the entire pest management industry. Be sure to leave a positive impression. Summary. Certified applicators often supervise and instruct uncertified individuals. The minimum standard for supervision of pesticide applicators is detailed under FIFRA. According to FIFRA, certified applicators do not necessarily have to be physically present during the application. Certified applicators, however, must be aware of any state or label requirements that have stricter standards. To perform pesticide applications properly, uncertified individuals need adequate training and supervision to become competent at their task. Supervisors must be able to communicate effectively with employees as well as customers and the public. Both certified and uncertified employees must be able to address consumer questions clearly and accurately. It is a violation of the federal pesticide law to misrepresent the safety and efficacy of any pesticide. Applicators must also be aware of and follow up on any pre-application notification or posting of treatment sites required by their state. Properly training employees, enforcing security procedures, communicating effectively, and adhering to federal and state pesticide laws all contribute to a professional image. Looking and acting professional enhances consumer confidence in the pest management industry. I just want to close out by saying this. Everything we do and how we carry ourselves every day is part of our professional image. We've talked about it throughout this course. The fact that you need to be able to communicate internally between management and employees, as well as externally with customers with respect, empathy, and understanding their particular situation. So make sure you go out there, you carry yourself professionally, and let's put a great image out there for the pest management industry.